Last video, I showed you some examples of piecewise defined functions, and I actually already read through this definition, but I'll read through it again. The definition of a piecewise defined function is when a function is defined by different equations on different parts of its domain. So in this first example, all we are doing is evaluating f of 0, f of 1, and f of 5 if this is my piecewise defined function. It looks like I forgot an x in here, but if x is less than or equal to 1, then we're going to use this linear equation right here. And if x is anything greater than 1, then I'm going to be using this cubic equation here. So for my first one, if I have f of 0, well, what part of its domain is that meeting the criteria? So if I have x of 0, does that mean my x is less than or equal to 1, or that x is greater than 1? Well, 0 is less than or equal to 1. So it means I want to be using this top linear equation. So we'll have 2 times 0 plus 4. 0 times anything zeroes out. So we have 0 plus 4, and that's going to give me 4 right there. So now we need to find f of 1. So which equation are we using here, the top one or the bottom one? Well, this top one says when x is less than or equal to 1, I have a value, an input that equals 1. So we're still using this top one here. So I'm putting in this number, that 1, and for this x, so 2 times 1 is 2, plus 4 gives me 6. And then lastly, we are going to find f of 5. Now 5 means that my x value is greater than 1, so I want to be using this bottom equation, this cubic. So we have 5 cubed minus 1. 5 cubed is 125, minus 1 gives me 124. So if you are just simply evaluating, you need to look at its domain and figure out which equation we are talking about here. And you could have 2 equations like this one here, or you could have 3 or more. I think most of your examples, though, will only have 2.